Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 318, minimum total distance traveled. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this contest. So looking back, I did about 13 minutes on this. To be honest, I really was convinced that there's another way to solve this, and that is using a very high machinery called min cut max flow, or min cost min cost min cut max flow specifically. Min cost max flow. I may be saying it wrong, but clearly I don't even know how to say it. I was actually going on that direction just because the way that this problem is structured, it's very natural to do it. The only reason why I didn't finish doing it that way is because I don't have the libraries for it. I imagine we probably see a couple of people doing it that way, and there are a couple of easy solutions there, and it's something that I imagine if you, and I don't know, I'm not saying anyone particular, but it's something that a lot of the people who have done competitive programming, they would have libraries for. I actually do have a max flow implementation somewhere, but not a min cost max flow. So then I was like, okay, well, yeah, because this is actually like almost like a sort of maximum bipartite matching type thing. So yeah, actually maybe we could have done it that way. In any case, the way that I did end up doing is with dynamic programming, and N is the the two sort of N's, if you will, one R for robots, one F for factories, and less than 100. So I thought, okay, we do something like R times F times R or something like this. That should be good enough. R times F or whatever. 100 cube is my goal. So that's basically the idea. The first thing to do is to sort the robots in the factory. This kind of gives it a structure. Also kind of allows you to create this optimal substructure that comes from sorting it on a line, so that now you can look at the robots from left to right and the factories from left to right. So then now you can match them from left to right together, and then there's no like weird robot choices, and that will allow you to come up with this this optimal sub problem structure that allows you to use greedy. Of course, greedy being this min function. Okay, we'll go over that in a second, but yeah, the first things first is to sort both the robots and the factory. Infinity is just infinity. Otherwise, this is a pretty small thing. I honestly also just if you've been on my channel long enough, you know that I always rant about Leetcode and Python and performance. So I actually was worried that this was going to be too slow and I have to like rewrite it again. But this time it was okay, so I'm very happy about that, because it just would have been much more annoying to convert it, or it just takes time no matter what, plus a 5-minute penalty, which I've done before, and had to convert to C++ or something, right? So I don't know. Anyway, but yeah, so the idea here is just that if we run out, it's infinity. Otherwise, yeah, and this is kind of almost, so this cost is kind of like a prefix sum. You can definitely actually probably do like a prefix sum on robot and not do it this way, but I did a rolling sum. So the idea here, and this is a kind of a weird base case of, okay, we went through all the robots, then the cost, then we don't have to do a recursion, we just do a cost and then we break. This also, some of this is just that this we probably could have put outside the loop, but I was a little bit, these things are always a little bit tough for me, not gonna lie, just because the ranges are a little bit weird, because this is a thing that I would if I was doing this in a C language with C for loop, I would, this statement would be in a loop. So so this is how I kind of get away with it without thinking about it too much. But yeah, so this is actually the second base case of we did all the robots. This is the cost, right? The cost is the sum of the prefix sum we run by. Otherwise, this is okay. Let's say we take one additional robot. What does it cost? Well, yeah, we add the cost, and then we go to the yeah, well, this starts at 0. That's why this is a little bit awkward. But so you could have also done it from 0 to 1, and maybe rewrite this a little bit differently. Maybe that's why it looks a little bit weird to me, because I think I write this usually in a little bit different way. Maybe like do r of I plus 1, so then now the base case is here instead of here or something like that, and then you just return 0. But that is why this is a little bit weird. I remember coding it and thought it was a little bit weird. But in any case, yeah, so this is just, going to the robot, the next robot that we have to care about, and this is the next factory that we have to care about, and this is the running cost. And of course, and this is just to add the next robot of, okay, now this is, if we want to add this robot to this factory, this is the cost of that, right? That's the distance it has to move. And then, and then this for loop will take care of it. This is a very awkward way of writing it, to be honest. But I guess if it works, it works. At the very end, we return best, and that's pretty much it. Hopefully that kind of makes sense. But do I have to draw it? I'm just thinking whether drawing it helps. But yeah, but the idea is just really one factory at a time. You just kind of take as many robots as the factory allow and then see what happens. So that's basically what the recurrence is doing. So what is the complexity, right? Well, Ri can go from 0 to R, Fi can, and from 0 to F, and yeah. So the total time is just, you go to time per input times number of inputs. The number of inputs is you go to R times F, right? And each input takes O of R time, right? Because this factory limited thing can at most be O of R. So yeah, so this takes O of R time. So then total time is going to be O of R squared times F. Space, you can kind of do it the same way, but except for that it is O of R times F. That's pretty much it. I guess technically if you really want to be specific, you have to do, oops, that's not on the space, my fault. Depending on, what the R's are and stuff like this, but that's pretty much the idea. So yeah, from the sorting, in case you're wondering. But yeah, that's pretty much all I have. So let me know what you think. And you could watch me solve it live in the contest next. Okay, good. Annoying but good. That's a yikes, but alright. Oh, that took a while. Debugging. What am I doing? Okay. What is n? 100? Is this going to be like maximum pi per day matching or something? That would be really ridiculous to do. Like if this is max for, I really have to pull up my max for libraries. Precision's 10 to 9. Do I have a max for library? I honestly don't think so. It's been a while. I have some like really old C code, but we'll see if this works. Maybe there's a DP solution though. But the limit thing makes it the DP not really. Is that true? I'm just looking over my Max Flow library. Man, it's been a while since I know what this code does. I guess we don't really have to do it explicitly, but okay. Let's see. Alright, not gonna lie, it's been a while, so I don't know if this I can code this from scratch, even with copying stuff. Yeah, let's just create an edge actually. That's not quite right, and that becomes 200 in that case. Is it DP? Is DP if we work out? This isn't. This is just min full. This isn't min cost. I don't have a min cost one written actually, so maybe I'm wrong on this. Okay, well let's not do that then. I mean, if I had a library, I would have done it, but I just don't. So that's a little bit sad. I guess it's just DP, but limit chains. Oh, whatever. Should be okay. And object not editable. That's not great. My base case is wrong. That's definitely not right. But this is just +1 is why. Alright, this is slightly better, but still wrong, so. Why does it think it is 6? This is 4. This is a little bit wrong. So 0 means that the cost is wrong. Okay, but is it fast enough? This time I'm actually trying. Usually I YOLO. 10, 20, 40, 50, 60, 70, 80, 90, 100. So if Leetcode is still not treating it well, then it is what it is. Should be 100 cube or something. Oh. Yeah, okay, fine. That is actually way annoying. Okay, then let's just do okay, 71 millisecond. I don't know what that means, but it seems fast enough. This has to be 100. I think is the worst case. Okay, I mean it's not fast, but I'm just hoping it is fast enough, and also right. Might be. Oh, cool. I really took my time on that one. Hey, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about, this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.